Hello and welcome back. Today we're going to look at two problems, both dealing with probability concepts and common probability distributions. So let's get started. So here we're given the probability of a beating expectations outcome is 60% and that of missing is 40%. Now the outcome is a discrete random variable. The outcome is also a binomial variable. So what we're dealing with is a Bernoulli random variable, and hence we apply the binomial probability function, which defines the probability of x successes in n trials. So we're given that x is 8 and n is 12. We're given the probability of beating expectations or of an x occurring as 0.6. We need it to occur in 8 of the next 12 quarters. So working out the numbers, we get the final answer as 21.28%. That makes B the correct answer. Let's take a look at another problem. So it's a very similar setup here, except instead of directly being given the probability of beating or missing expectations, we're given the odds against as 4:7. This means that the odds for beating analyst expectations is 7:4, and that really is the only differentiator between this problem and the previous problem. So once we know the odds of beating expectations are 7:4, we know that that implies that the probability of beating versus probability of missing equals 7 over the total number of parts, which is 11, divided by 4 over 11. And this implies that the probability of beating, which is the number in the numerator, is 7 over 11. Which equals 63.64%. The rest of this is very similar to the problem we've just solved. And this is again a Bernoulli random variable. So we apply the formula relating to the binomial probability function, which defines the probability of x successes in n trials. In this instance, x is 3 and n is 4. The probability of exactly 3 successes in 4 trials, in other words, the likelihood that Widgets Inc. will beat expectations in any 3 of the next 4 quarters, equals 4C3 multiplied by the probability of beating expectations in any given quarter, raised to 3, multiplied by the probability of missing in any given quarter, raised to 4 minus 3, or 1. We plug in the numbers and we get a probability of 37.49%. So the only wrinkle in this problem was that we had to take a probability expressed as odds, make sure that we inverted that probability to properly reflect the probability of a successful outcome in the Bernoulli trial, and then plug in the numbers into the binomial probability function formula. I hope you found that useful. Good luck as always, and I'll be back soon with more videos.